If your C++ code is getting big and messy in one file, it's time to break up into small parts. In this tutorial, we will see how to run multiple C++ files using Clang step by step. Why using multiple files? In real-world coding, we don't write everything in one file. Instead, we split our code into smaller files for better readability and structure. For example, our basic file of hello world will look something like this. This is very simple hello world code. When we execute it, we will see hello world as the output. You can see on the screen. We are using here command clang filename.cpp and -o tell us that what output file I will need to convert our executable into. That's why -o hello /hello we are executing, and then we are seeing the hello world as the output. This simple hello world can be split into multiple files as follows. File with main.cpp. It will contain the main logic from where our execution of the code will start, and utils.cpp. It will contain helper function which will contain the logic how to print on terminal, and utils.h contain the function declaration which will contain the declaration of the function in which cout is implemented. Here if you notice, we have a file with an extension .h. This file is known as a header file. In simple terminology, we can say that a header file is where we declare what function we need, and the .cpp file defines what this function will do. Let's see how we can break this down. As we have discussed earlier, we can split our hello world code in 3 separate files. Let's see their content this time. You can see the folder structure. Let's start with file utils.h. This is header file and it will contain the declaration of the actual function which we going to use. In C++, these three are used together as an include guard to prevent the same header file from being included multiple times during compilation. This simple if guard ensures that the content of the file are only processed once, avoiding issues like duplicate definitions. It's like saying, if this file has not been included yet, include it now. In more simple terminology, a header file is a place where we say what function we need, like a blueprint, while the actual logic or implementation is written in corresponding CPP file. Let's move to now our CPP file. You can see the code on screen. If you see the first line, #include IOStream. This is standard system header that provide input and output functionality like std_cout. The angle bracket tells the compiler to search system directories. And second line, #include utils.h. This include a user-defined, that is our header, where we have declared the function and print message header file, typically located in your project folder. The double quotes tell the compiler to look in the local project directory first. And our function void print message. This function is defined in utils.cpp and likely declared in utils.h. It will simply print hello from utils to the console. So what we have concluded from here, if we are using #include with angle bracket, then our compiler will look in the system header like standard library. If we are using double quotes, it used your own project headers or where you define the path, your custom header. Step by step how we can compilation. So step 1, we need to first compile each file separately. Clang ++-c main.cpp, clang ++-c utils.cpp. Here the -c flag tells the compiler to only compile the source file into the object file and not link them into an executable. So main.cpp become main.o, utils.cpp become utils.o after this step. Each .o file is known as object file, is a machine code representation of the corresponding CPP file, but it's not yet fully executable. This object file can be reused. If only one file changes, you don't need to recompile everything. This step is important in large project where compiling everything in one go would be inefficient. Once we have compiled them, then we have to link it. So clang ++main.o utils.o -o my program. This links both object file into a single program. Executable name with the output as my program. So we have to run that. So we will just hit /my_program. So we will get output as hello from utils. Even this we can do in one step. Clang ++main.cpp utils.cpp -o my program. This is a quicker for smaller project, but for large code base, it's not ideal. This solution leads to a problem with many files. Let's suppose your project basis consists of 20, 50 or more than that files. So it's very tedious to write clang ++ file 1, file 2, file 3 till file 50 and then my program. So for that purpose, in real world project, people use Makefile to automate the build process. So instead of typing long command, you just write make and everything will build automatically. In next video, we will create a Makefile of our own and understand what it is or how we can use Makefile.